All right, hey there. We're gonna jump into the next chapter. This is just, I guess, how it's gonna be. All right, so hopefully you have your pair deck there, whether it's in front of you on another slide here, or you just have it printed out, or you just can take some notes with it. That's fine. All right, so first thing is which one doesn't belong. Hopefully, in this, you can make a choice here. I know some of us might be saying, well, this one opens down. This one has a vertex below, but this one, I think this is the one we're going for because it doesn't look like a U shape at all. Right, and that's what we're talking about. In this chapter, we're going to start dealing with these quadratics a little bit more, but more so the graph and how they look. And these are all those U shapes, and we talked about vertex a long, long time ago, it feels like. So this one's linear, and the other ones are quadratic, right, or x squared. Linear, remember, is x to the first power. Right, so that's what we're after. Trying to take a look at some of those. So here, this just recalls all the vocabulary. So let me grab my highlighter. Say this is the vertex, right? We can call it a min or a max. Okay, but that vertex is just the highest or the lowest point that we have, and that's based on whether it opens up or opens down. So just some other things to point out here. If A is greater than, right, that means positive. So if the A value is positive, then it's going to open up, right? It's like a smiley person. I saw this one the other day. A is greater than 0. That face looks like this. If A is less than 0, okay, then that face looks like that. So you get those sad faces and happy faces. Hopefully we have a lot more positive A's out there so that you're super duper happy. Now, the other thing we have is the axis of symmetries in both of them. And notice it goes right down through the vertex, and that's always going to be an x equals whatever that number is. X equals whatever that number is. Okay. Seems a little bit backwards. The only point is if it's very, very bottom, that's the minimum, and that happens on your positive ones versus the negatives. So that's all vocab driven. That's how we're going to ask questions in this chapter, so we're going to make sure we take some time and study that vocabulary. All right. What's the vertex of the graph? Well, that's this point right here, the very, very bottom. So we have to make sure that we went -2, -3, -2, -3. So here we go. And this happens to be the lowest point on that graph, because from there it's going to go up and up. So that makes it the minimum point. So just reviewing that idea that positives go up and they have a minimum. What's the vertex? We get this point here. So this one sometimes gives kids some trouble. Notice on X we went nowhere, so 0, and then went up 2. And since that's the very bottom, that is a minimum point. This one here, don't let that confuse you. 1, 2, 3. That's actually 0, 3, and that's the very top. So that's the maximum value we'll ever get for this quadratic function. All right. What do we got next? We're going to graph. We got -3x squared. So we know that it's not going to move anywhere. It's going to start at 0, 0. If we don't know what to do with it, we can always just make a table. So we know if I put in 0, I get 0. If I put in 1, right, I get 3, 1 squared. So 1 squared is 1, so I'm going to get -3. And if I put in -1, -1 squared is still +1, so I'm going to get -3 again. So 1 gives me -3, and we'll get the reflection of that off the other side here. So we'll be able to connect those 3 points to get a picture of the graph. Alright, so what we know is this opens down, a lot like slope to a line, but it's not linear, but we're going to get that down 3 and over 1 to get started with it. Domain. So that's our x values, and that's going to be all reals, because this will continue left and right forever. The range, however, has to do with the y values, and this one is usually pretty tricky for kids. So notice that this is the very top of it, right? This is the maximum value. So my range is the y has to be less than or equal to, it will reach up to 0, but it never goes any higher than that. So it's based on whether it opens up or down. And we'll know that from that A value as we work through this chapter. So let's try that again. We get another one of those for the 1/3. Okay, so this time, if we're not sure, we're going to make a table, but we have an idea that it's going to open up and that it's going to go up 1 and over 3. So let's get an idea of what happens with that. So plug in 0 and we get 0. If I plug in 1, I get 1/3. If I plug in -1, right, 1/3, -1 squared. So I don't want to skip over what I'm doing here, because if you have any questions at all, you just make a table, plug some values in. So I'm going to get 1/3. Alright, so how that works is if I go over 1, I go up 1/3. And if I go to -1, I get 1/3. And we have these points going on. So this 1/3 has made this graph extremely wide. Domain, we're going to get tired of this one. All reals. And the range, this time, y is opening up, so greater than or equal to 0. So this is that add-on. And what you'll start to get used to is this is a lot like when we dealt with the absolute value. Except for in the absolute value, we had V-shapes, and then we'd start to move them around. And that's what we're going to do in this chapter, except for they're going to be U-shapes. But the positive A, negative A makes it open up versus down, and the domain and range is going to be very, very similar. So everything that you remember about absolute value, that's going to help you carry over as we graph a few things in this chapter. Alright, let's see if we have this figured out now. We want to go with the widest one. So what I'm looking for is I don't care if it has negative or not, if it opens up or down. So the widest thing is actually going to be this one here in the middle. The next widest is going to be the original one, because we have 1 as the A value. And then the last one, the 4, even though it's negative, and we don't care about the negative, that just means it opens down. It's going to make it pretty narrow. We have those in order. Alright, so we tried again, this time without the picture there. So if I want the widest is going to be the smallest number that I have. Okay, so if I have, and I don't care about negative, so I have 1, 3, and 1/3. So the smallest number is 1/3. The next smallest number I have is 1. And then the largest number I have is 3. So that puts them from widest to narrowest. Alright, so here's where you get a chance to kind of follow up with that. To take a look, give examples if you want. We're going to put something in here so you can describe how do you know widest to narrowest. Alright, next slide I have, alright, because you have to pause that. Alright, you pause that, you did a couple things there. Alright. But I don't want these videos to go on forever, so you have to work with pause every now and then. Alright, so I have Desmos in here. So some things we want to notice is when it says +5, that means your parabola is going to move up 5. So we can make some predictions, x squared minus 1. So x squared, and we're going to go with minus 1. Alright, that's exactly what we thought it was going to do. It's that U shape, but it's been moved down 1. X squared plus 2. X squared and plus 2. We know it should go up 2, and it opens up. So last one, I made sure we had 1 in here that goes that opens down. Negative x squared, and we'll go with plus 2. That looks pretty cool, I'm not going to lie. Then I do like purple, it's one of my favorite colors. So it does open down. So this one, we change up the range, but the domain is the same for all 4 of these. And just like we were talking about, it's not in our list, but if you weren't sure about making those wider or not, we can always put in maybe 5x squared. And you kind of start getting the idea beforehand, before you hit enter on that. Is that going to be really wide, or is it going to be really skinny? So we can get rid of some of these. I take those out. Okay, so what would be something that's more narrow than 5? What if I put in 15? That's pretty narrow. What if I wanted something really wide? I might put in 0.5. It's a little bit faster than typing in 1/2. What if I made a 0.05? 0.005. Now we're starting to talk about things you would see on arcs on bridges. You do really, really wide. because it has to cover along a distance left to right. So we start doing some of that. And so trying to re-emphasize what we just talked about. Alright, so here's where we're at. If you're not sure, at this point, this clears it up with a table. For the most part, we're just filling in some numbers. So negative 2 times negative 2 is 4. So we're going to get negative 2 is 4. We got negative 1 is 1. 0 gives me 0. 1 gives me 1. And 2 squared gives us 4. So we wrap this guy right around. So we get our first one. Now we know from the graph exactly what's going to happen. This minus 3 moves this down 3. 1, 2, 3. So I know right away 0 is paired with negative 3. I want to take each point and move it down 1, 2, 3. So we're just translating these points. So I know from the graph 1 gives me negative 2. Or if I plugged it in, negative 1 times negative 1 is 1, minus 3 is negative 2. And we're going to get a perfect picture of this whole thing using the axis of symmetry. I'm going to move those out just a little bit. There we go. Alright, so those extra red dots, it looks kind of evil. I like it. Use evil for good, right? Especially in parabolas. So we're going to move those down. So one SAT style question, prepping you for next year sometime, is sometimes asked what happens to the table. Well, all these values went down 3. So just making some connections between not just what happens in the equation difference, the graph difference, but also in a table. So for what it's worth, I'll make sure we're going to put that in front of you. Alright, where's it used in life? With acorns, of course. Okay. So I got a lot of squirrels around right now. They're still pretty hungry. They're digging up holes in the yard. One of them might be up in a tree 70 feet. At time 0, the squirrel is pretty happy. It's holding on to its acorn up there. And let's say it's not the most athletic squirrel, so it actually dropped its acorn. So what we're going to do is plug in 1 second and square it and find out the height as we work through a table here. Alright, so essentially we're just making this table. So we find out is we're with negative 16 times 1 plus 70, so that's going to get us down to 54 feet. So 1 second, 54. So what do we have so far in our table? We have time, and we have the height. So 0 was 70, 1 was 54, 2, let's plug in 2, so we go to 2, so we need 4. Alright, so where are we at? We're at 64. Alright, so now we're down to 6 feet, so 2 seconds, we're at 6 feet. Alright, so I'm pretty sure about what time, it's going to be a little bit more than 2 seconds. Okay, so at 3 seconds, if you do a calculation, we're getting negative 74 feet. So it's definitely closer to 2. So between 2 and 3 seconds will do. And we're getting just this half of that parabola. Alright, pretty cool. Alright, so we have just a quick review. So I'm going to jot your numbers in order. How are these different? Okay, so plus 5 without it, and a coconut drops from the ground. So just a quick review of what in the world we talked about today. So make sure you get that in your pair deck so I can take a look at that. And what I'll try and do with each of these is put in something fun at the end. My favorite parabolas are all from Super Mario. We're all trying to get some work done. We're trying to have some fun when we can. So there's a parabola for you. And if you want to, you can add in anything else that you'd like if Super Mario is your game. If not, I always have a slide at the end as well. If you just want to draw a picture, if you want to type in some questions, any concerns you have, that way I have a heads up before we get a chance to really talk about anything.